What's up, everybody? Got another video here for you. This is business calculus, integration by substitution. All right, so before we get to the integration by substitution, let's recall a few things that we've already learned. Well, we know if we integrate x raised to a power, x to the n, then remember you add 1 to the exponent, and then you multiply by the reciprocal of your new exponent. So n plus 1, and then you multiply by 1 over n plus 1. And of course, this is when n is not equal to -1. And then the integral of e to the x is just e to the x plus c. And the integral of 1 over x is natural log. Remember, absolute value of x plus c. So that's basically what we're gonna use to do these integrals. And the one thing that you've got to understand about integrals is most of the time the integral that you have is not going to look like one of these formulas here. So that's our job, is to make something like this look like one of these. Okay, so let's look at this at these examples here. We got quite a few examples, and we got some word problems to do, so make sure you watch to the end so you can see the word problems. All right, so looking at this problem, you notice that this it doesn't look anything like those. Yeah, we've got x to a power, x to the first, we've got x squared, but it's this times, and then we've got this thing here in parentheses. So whenever you're looking at problems and you see something maybe like something in parentheses raised to a power, a lot of times what we want to do is look inside of those parentheses and say, what is the derivative of this inside the parentheses? Well, what's the derivative of 4x squared minus 3? It's 8x, right? And there's 8x outside, notice that. So what we want to do here is we can say, okay, let's let u equal 4x squared minus 3. And then if we do the differential here, that's 8x dx, right? You remember back when we were, I don't remember what video it was, but it had something to do with approximations and differentials in that section. If you had y equals f of x, then dy would equal f of x dx. Okay, that's what we're doing here. All right. Now, notice that we have a 8x dx. That's equal to du. Well, look at this, 8x dx. And then we've got the 4x squared minus 3. The 4x squared minus 3, that's what we let u equal. So if you look at this, you see the 8x dx. We can replace all of that with du. And then the 4x squared minus 3, we can replace that with u. And so that's going to give us u du. Well, u to the 5th, I'm sorry. See, I plugged u in for 4x squared minus 3, so that gives me u to the 5th. See, all of this got replaced with u. And then the 8x dx, well, all of that got replaced with du. And so now we can integrate. That's u to the 6th, and then remember, add 1 to the exponent, and then multiply by the reciprocal of your new exponent plus c. Now, do you see what we did here? We took this right here, this problem right here, and we ended up with this, which is now, as you can see, in this form right here. And that's what we did. Now, remember, our original problem is in terms of x, not u. And so for this, we get 1/6. And then we've got to substitute this back in for u. So that's 4x squared minus 3 to the 6th plus c. And there's your answer. All right. So it's that easy. All right, let's look at this one. Now, remember what I told you. When we have something in parentheses raised to a power, that's typically what we want to let u equal. Well, do we have anything in parentheses raised to a power? Absolutely. Isn't the square root of 2x plus 7 the same thing as 2x plus 7 raised to the 1/2? Same thing. All right, now, look at this. Remember what I told you. Look inside the parentheses and take the derivative of that. And is that derivative outside? Well, let's check it and see. So if we let u equal what's in the parentheses here, then du is equal to 2 dx. All right. So I just differentiated the 2x plus 7, and that gave me 2, and then times the dx. Now, look at this. Notice we have the dx, but we don't have the 2. You see that? Well, we need a 2, don't we? So I tell you, it would really help if we had a 2 right there. And then see, then we would have 2x dx, just like this, 2x dx. So how about I just multiply that by 2? But the question is, can we do that? That might be what you're thinking. Well, how can you just multiply it by 2? And you're right if you're thinking that, because we can't just multiply it by 2 because it changes the problem. But think to yourself, what's the only number that we can multiply to something and get the same thing back? Well, 1, right? 1 times anything, you get the same thing back. All right. So what I'm going to do, if I multiply by 2, I'm going to come out here and multiply by 1/2. So technically what I did is I multiplied by 1/2 and I multiplied by 2. Well, if we come over here, what is 1/2 times 2? That's 1. It's just a different way of writing a 1. I just wrote it as 1/2 times 2. I just put the 1/2 out here. I put the 1/2 out here and the 2 here, but it's the same thing. It's 1/2 times 2, because the numbers here, I can move in and out of the integral symbol. Okay, and so now I'm going to get 1/2 times the integral, and then the 2x plus 7, that's going to be replaced with u, and then the 2 dx is going to be replaced with du. And now you can see I have this in the form x raised to a power. And so when I integrate that, that's 1/2, and then that's going to be u to the 3/2, right? Add 1 to the exponent, that gives me 3/2, and then I've got to multiply by the reciprocal of the new exponent, and then that's plus c. And so this is going to give me 1/3 times, and then in the place of u, I've got to put the 2x plus 7, and then that's to the 3/2 plus c. And there's my answer. All right. All right, I had to pause the video for just a second because I had to plug my laptop in. Battery was running low. All right, let's look at this one. Now this one's strange. This has x to a power and e raised to a power. And you can see I've got an x to a power and I've got an e to a power. Well, that's kind of crazy. Well, if you have the e in there, e raised to a power, one thing that we like to try is maybe looking at the exponent here. Okay, look at the exponent. What's the derivative of this exponent? Well, let's see. If I let u equal x to the 4th plus 2, then du is 4x cubed dx. And you can see here, I have an x cubed and a dx. See, I have this x cubed dx. I'm missing the 4. So what am I going to do? I'm going to multiply by 4, and then I'll come out here and multiply by 1/4. And so now I've got the 4x cubed dx, which I have here. So now I can make my substitution. So that's going to be 1/4 integral e to the u. Okay, so I'm replacing the x to the 4th plus 2 with u, and the 4x cubed dx, I'm going to replace that with du. And now you can see I have this form up here, e to the x. Okay, and so this is equal to 1/4 e to the u plus c. And then I have to substitute this back in for u. So that's going to be 1/4 e raised to the x to the 4th plus 2 plus c. And there's my answer. All right. Now let's look at this one. I mean, if we look here at this denominator, that's x to the 5th plus 1. What's the derivative of this? Well, let's look and see. U equals x to the 5th plus 1. So du is equal to 5x to the 4th dx. All right. So this problem here, this one, I mean, it's not different, but the constant, the number in front of x to the 4th up here is a 2. We have a 5. So basically what we need to do is figure out, and this is one way to look at it, but I'm going to show you something that'll make it a little easier. We need to figure out what can I multiply to 2 so that it'll be a 5, because that's what I need in front of x to the 4th. I need a 5, right? And when you're sitting there thinking about 2 times what is 5, I mean, you know, obviously it's not that difficult to figure out, but let me show you something that makes it a little easier. So if you notice in this problem right here, when I let u equal 4x squared minus 3, then I got du is 8x, and that matched exactly. So we didn't have to do anything. And then in the next problem, we were missing the 2, so we just multiplied by 2. Here we were missing a 4, so we multiplied by 4. Here we need a 5, but we can't just multiply by 5 because we have a 2 here. So when that's the case, whenever you do your du and this number here doesn't match this number here, what I like to do is rewrite this problem and pull that 2 out. Just pull the 2 out if it doesn't match. And so now we can see, okay, well, I can multiply by 5, and that means I have to go outside the integral and divide by 5. See there? So now I have 2/5 integral. Now, look at this. See how I have 5x to the 4th dx? Well, that can be replaced with du, and then the x to the 5th plus 1 can be replaced with u. And so what do I have now? Well, this is like this one. And basically what it is, you see how this is 1 over x dx? Isn't that the same thing as dx over x equals natural log absolute value of x plus c? I mean, the dx can be out here or it can be up here in the numerator. It doesn't matter. This is the same thing as this. And that's what we have. We have du over u. And so now we have this is 2/5 natural log absolute value of u plus c, which is equal to 2/5 natural log, and let's substitute this back in for u. That's x to the 5th plus 1 plus c. And there's your answer. So just remember, when you do use the U-substitution, you've got to you've got to get it back in terms of x. Okay? All right, let's look at this one. All right, so, well, when we look at this one, if we let u equal x minus 1, then du is equal to dx. So if you look at this, well, there's my dx, but what about this x right here? What do I do with that? Because that's not helping anything. It's nice when the only thing that's wrong is a number doesn't match. Because if a number doesn't match, you saw what we did. We just multiplied by the number and then went outside the integral and multiplied by the reciprocal of the number. But we can't do that when the variable. See, we actually see if that was an x right there, that would be nice. But what can we do since that's a variable? Well, remember, we want to get everything in terms of u. So if we look at this, I've got x minus 1, that's u. So I'm going to put u in the place of x minus 1. But I need to know, what is x? What does x equal? Well, can you see here that x is equal to u plus 1? See, if I take this and solve it for x, I add 1 to both sides. And so now I can do u plus 1 over u du. So in the place of x, see, the place of x, I put u plus 1. In the place of x minus 1, I put u. And in the place of dx, I put du. And so now when I integrate this, this is going to be u over u plus 1 over u du, which this is going to be the integral of 1 plus 1 over u du. And so what's the antiderivative of 1? That's just x plus, and then the antiderivative of 1 over u, that's not x, that's u, we're in terms of u, is the natural log of u plus c. And then I need to get everything back in terms of x, so in the place of u, I have to put x minus 1, so x minus 1 plus natural log x minus 1 plus c. And there's your answer. All right, let's keep going. Oh, look at this one. This one looks terrible, doesn't it? So obviously what I'll do here is I'll rewrite this as 3x plus 6 over 2x squared plus 8x plus 3. That's to the 1/2 dx. All right, so let's see what we can do. So let's let u equal what's in the parentheses. So we're going to let u equal 2x squared plus 8x, and then du is equal to 4x plus 8. That doesn't help a lot, does it? And what I'm going to do is I'm gonna move this down some, because I think we're going to need a little more space right there. Let me move it down even a little bit more. We're going to have to do some rewriting. All right. So I've got, oh, I'm sorry. I didn't put my dx there. So we've got 4x plus 8. Up here we got 3x plus 6. Those don't match at all, do they? Well, let's see what happens here. What if I do du equals 4 times x plus 2 dx? Factor a 4 out. So we factored a 4 out. Up here, let's factor out a 3. So we've got 3 times x plus 2 over 2x squared plus 8x plus 3 to the 1/2 dx. All right, so we got the x plus 2, those match. But here we have a 3, here we have a 4. See, that 4 doesn't match that 3. So let's even rewrite it one more time. Let's pull that 3 completely out. So that's x plus 2 over 2x squared plus 8x plus 3 to the 1/2 dx. And so you can see here we need to multiply this by 4, so that means we've got to divide by 4 outside the integral. And now let's make our substitutions. So I've got 3/4 integral. So this is going to be 1 over u to the 1/2 du. See, the 4 times x plus 2 dx, that's going to be replaced with du, and then I've got the 1 over u to the 1/2. And yes, if you wanted to take the du and put it up here in the numerator, that's fine too. And so this is going to be 3/4 integral u to the negative 1/2 du. We got it in the form x raised to a power. And so that's going to be 3/4. That's going to be u to the positive 1/2. Negative 1/2 plus 1 is 1/2. Multiply by the reciprocal of your new exponent. And so that cancels. That's going to be 3/2 times 2x squared plus 8x plus 3 to the 1/2 plus c. And if you wanted to write it as 3/2 times the square root 2x squared plus 8x plus 3 plus c, that's fine. Okay, if you want to change the 1/2 to a square root, that's fine. If you want to leave it as a 1/2 power, that's fine with me if you're in my class. All right, so let's go to the next one. All right, so what about this one? We've got natural log of x squared. So let's let u equal natural log of x. So du is equal to 1 over x dx, right? That's the derivative of natural log x. And hopefully you can see this. If you can't, let's look at this. What if isn't this the same thing, natural log x squared times 1 over x dx? This is the same thing as this, because if you do 1 over x times natural log of x squared, you end up with this. I just separated them so you could see the 1 over x. And so now let's make our substitution. That's going to be u squared du, right? So what we did here is, I replaced the 1 over x dx, replace that with du, and replace natural log x with u. And so this is going to be u cubed, and then times the 1/3 plus c. So this is going to be 1/3 natural log x cubed plus c. And there's your answer. All right. See, I mean, it's all the same thing. It really doesn't matter what we have here. It's just U-substitution. You're just trying to make all of these problems look like those 3 formulas at the beginning. Okay, let's look at this one. All right, well, this one's easy. We're going to let u equal 5x plus 2. So du is 5 dx. Well, what are we missing? We're missing a 5. We need 5 dx. So I'm going to multiply by 5, go outside and multiply by 1/5. And so this is going to be 1/5 integral e to the u du. When we make our substitution, the 5x plus 2 is being replaced with u, and the 5 dx is being replaced with du. And so this is 1/5. Let me write that better. That's 1/5 e to the u plus c, which is 1/5 e to the 5x plus 2 plus c. And the one thing about this, you can always, these answers you get, you can take the derivative and see if you end up with the function that you're integrating. All right, so let's look at this one. This one's a little different. We've got x squared plus 3x plus 5 over x plus 1. All right, so when we look at this, I mean, if we were doing derivatives, first thing that would pop in my mind if I was finding the derivative of that, we would think a quotient rule. But there's no quotient rule for integrals. So what do we do here? Well, I need to figure something out. What if I divide this into this? Let's try that and see what we get. So I've got x plus 1, and then I've got x squared plus 3x plus 5. Do long division with polynomials. Now, you are in business calculus, and it is assumed that you know how to do long division with polynomials. I'm going to kind of explain what I'm doing as I'm doing it. But if you need some more help with doing the long division of polynomials, just search my YouTube channel. Just type in long division of polynomials and watch that video. It goes into more detail explaining how to do this. So basically what we do is we look at the x here. What do I have to multiply to x to get this first term? Well, that would be x, right? So x times x is x squared. X times 1 is x. And so then I draw my line and I subtract. But what we're going to do is we're going to change the sign of each of these and add. Okay. Do you remember back when you had something like 5 minus 2? I know everybody knows this is 3. I understand that. And we would never work this problem the way I'm fixing to do it. But remember when you were learning to add and subtract integers? So when you subtracted integers, remember you learned to change the sign. This is 5 minus positive 2. You would change the positive 2 to a negative 2 and add. That's what we're doing. We're changing the sign of each of these and adding. So this is 0. This would be 2x, and then you bring down your next term plus 5. All right. And then what do we multiply to x to get 2x? Well, we got to multiply it by 2. So 2 times x is 2x. 2 times 1 is 2. We're going to change the sign of each term and add. And so we get 3. And so what we have here is x squared plus 3x plus 5 over x plus 1 is equal to x plus 2, right, the quotient, plus the remainder over the divisor, right? That's what that's equal to. So now what we can say is that this integral here is the same thing as the integral of x plus 2 plus 3 over x plus 1 dx. So this is equal to that. Because I just divided. This is the same thing. All right. So look at this. I can divide. I can integrate the x. I can integrate the 2. But then look at what happens when I have to integrate the 3 over x plus 1. Well, let's do some rewriting here. So that's x plus 2 dx plus the integral 3 over x plus 1 dx. So why did I separate them? Well, because on the x and the 2, I don't have to use U-Substitution, but on the 3 over x plus 1, I have to use U-Substitution. And so using U-Substitution on this one, if I let u equal x plus 1, then du is equal to dx. And notice I don't need the 3 there. You see that? I don't need that 3. So I'm going to actually rewrite this one more time, x plus 2 dx plus, and I'm going to pull that 3 out, okay? And that'll leave me with dx over x plus 1. Or, I wrote dx over x plus 1. If you wanted to, you could write 1 over x plus 1 dx. It's the same thing. It doesn't matter if it's up here in the numerator or if it's over here on the side. Okay? Doesn't matter. And so now I get the integral x plus 2 dx plus 3 times the integral. So we got du over u. So I'm going to replace the dx with du and replace the x plus 1 with u. And so now we have x squared times the reciprocal of your new exponent plus, and then the integral of 2 is 2x plus 3, and then what is this? That's one of the formulas at the beginning. That's natural log absolute value of u plus c. And so now this is going to be 1/2 x squared plus 2x plus 3 natural log, and what is u? U is x plus 1 plus c. And there's your answer. Okay. So that one was a little more involved, but it's not that bad. All right, so let's look at this one. All right, so for this one, I can let u equal what's down here on the bottom, what's in the denominator, but that's not going to give me anything close to the numerator. I mean, just look at this. Don't write this down if you're taking notes. If we let u equal that, then du would be what? Derivative of 1 is 0. Derivative of e to the negative x is e to the negative x times the derivative of the exponent, which is -1 dx. That doesn't even come close to what's up here. We can't, we can't multiply by e to the negative x. So what do you think we might could do here? Well, sometimes it helps to rewrite the integral before we even try any U-substitution or anything. So if I look at this, this is the integral of 1 over 1 plus 1 over e to the x dx. Right? I can look at this as being over 1, and I can move this down to the denominator. That changes the sign of the exponent. So that would leave me with 1 over e to the x. All right. And so now we need to simplify this thing. So do you remember how to simplify these things? I'm going to multiply everything by e to the x. Right? This is a complex fraction. See, I can look at that as being 1 over 1, that as being 1 over 1, and if I look at this one, and this e to the x, all those three denominators, the common denominator is e to the x. So I'm going to multiply each term by e to the x. And so that's going to give me the integral e to the x over e to the x plus 1 dx. And so now let's try U-substitution. So I'm going to let u equal e to the x plus 1. I'm going to let it equal this denominator here. And so du is e to the x dx. Well, look at that. That worked out perfect, didn't it? And so now this is the integral. I'm going to replace the e to the x dx with du and replace the e to the x plus 1 with u. And so that's just what? That's natural log absolute value of u plus c, which is natural log absolute value e to the x plus 1 plus c. I've got to get it back in terms of x, so I've replaced the u with e to the x plus 1. So, I mean, it looked like a complicated one, but it wasn't too bad. All right, let's see. Oh, goodness, let's see. I think this is our last problem here, and it's a word problem. I always got to have a word problem in the video, right? Especially when you're in business calculus. All right, so for this one, it says the price P dollars of each unit of a particular commodity is estimated to be changing at this rate. This is telling us the change in price. That's how the price is changing. Where X hundred units is the consumer demand. Suppose 400 units, where X equal 4, are demanded when the price is $30 per unit. Find the demand function P of X. And then at what price will 300 units be demanded, and at what price will no units be demanded, and how many units are demanded at a price of $20 per unit. All right, so let's see what we can do here. All right, so for part A, I'm going to write down that function again. dp dx is equal to negative 135x over the square root. And you know what I'm going to do? Instead of writing square root, I'm going to write 9 plus x squared to the 1/2. Okay? So it says find the demand function p of x. So basically, if this is dp dx, so basically this right here represents the derivative of p. So how would we find p of x? Well, we would integrate dp, the derivative of p. We would integrate that to get p. All right, so we've got p of x is equal to the integral of negative 135x over 9 plus x squared to the positive 1/2 dx. That would be p of x. All right, so here we go, U-substitution. We're going to let u equal 9 plus x squared, so du is 2x dx. So here we go. Once again, we see that the negative 135 does not match the 2. Well, what did we do earlier when that happened? Well, we just took the negative 135 and moved it out. X over 9 plus x squared to the 1/2 dx. So what do? I'm going to multiply by 2, come out here and divide by 2. And so this is going to give me negative 135 over 2 times the integral. Now the 2x dx, see 2x dx, that can be replaced with du, and the 9 plus x squared, that's u to the 1/2. And so this is going to give me negative 135 over 2 times the integral, and we're going to have to write that as u to the negative 1/2. We got to move it up, so now we can use that property x to a power. And so that's going to be negative 135 over 2. That's going to be u to the positive 1/2. Negative 1/2 plus 1 is positive 1/2. So there's my new exponent. Multiply by the reciprocal of your new exponent plus c. And so this is going to be negative, that's going to be negative 135 times 9 plus x squared to the 1/2 plus c. And so that's going to give me p of x is equal to negative 135 times the square root of 9 plus x squared plus c. All right. All right. Now we've got a bit of a problem, don't we? Because they're wanting to know at what price will 300 units be demanded. So in other words, we take the 300 and remember the units, the number of units. Where is it? We're x 100 units. So whatever number we plug in for x, that means 100. So that means for the 300 we would plug 3 in for x. So basically for part B, they're wanting us to plug 3 in for x and get an answer. But what's the problem that we have? Well, the problem we have is that plus c. We don't know what c is. You see that? But if you notice up here, it tells us, suppose 400 units, which means x equal 4, are demanded when the price is $30 per unit. Oh, so they're telling us if we plug 4 in for x into our into p, if we plug 4 in, we should get 30 as an answer. So what this is saying is that p of 4 is equal to negative 135 times the square root of 9 plus 4 squared plus c, and that should give us an answer of 30. And you notice here we've got an equation we can solve. And so if I take negative 135 times the square root of 25, that's 9 plus 16 is 25, plus c equals 30. And so c is equal to 30 plus 135 times the square root of 25. And yes, I know the square root of 25 is 5. I just added this to both sides. See, add 135 square root of 25 to both sides. Add 135 square root of 25 to both sides. And then when you punch that into your calculator, let me see, what do you get? We get 705. And so what that tells me is that P of X is equal to negative 135 times the square root of 9 plus X squared plus 705. And there's your function, the demand function P of X. And then it says, at what price will 300 units be demanded, and at what price will no units be demanded? So they're wanting us to plug, remember this would be X equal 3, and no units, that would be X equals 0. So for part B, they want to know P of 3. Let me write that 3 better. P of 3 is equal to negative 135 times the square root of 9 plus 3 squared plus 705. And that will be, let's see, I've got the answer right here. It is $132.24 per unit. And then they want to know P of 0. Well, that's negative 135 times the square root of 9 plus 0 squared plus 705. And that is equal to $300. $300 per unit. All right, and that's what they're wanting to know for part B. And then for part C, it is saying, let's see, part C. How many units are demanded at a price of $20 per unit? So what they're saying here is, okay, so if the price is $20, how many units are demanded? So they're wanting us to take this, set it equal to 20, and solve for X. And so let's see, that's going to be negative 135 times the square root of 9 plus X squared plus 705 equals 20. And yes, that is a 20 there. All right, so this is going to give me negative 135 times the square root of 9 plus X squared equals, and then 20 minus 705, that's going to give me negative 685. And so that's going to be the square root of 9 plus X squared equals 685 over 135. All right. And 685 over 135, that's square root of 9 plus X squared is equal to, so if I do that in a calculator, that's going to be 25.75. Let me double check that and make sure. 685 divided by 135. No, that's not right. It's actually 5.074074. And then we square both sides, so that's 9 plus X squared, and if I square that, I get 25.746 and more decimals, so we'll round this to 25.75. And then I need to subtract 9 to both sides, so X squared is equal to 16.75, and so X is equal to 4.09. Now, keep in mind that when we square root both sides, that is plus or minus, but we know we only need the plus because you're not going to demand negative units. So we would say about what? 409 units because remember, x is hundreds. So 4.09, that's 409 units. Will be demanded when the price is $20 per unit. Okay. All right, so that is the end of this wonderful video. It wasn't bad. Pretty good video. I hope this helped you. I hope you enjoyed it. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.